This is Greg Troutwine with Maritime Reporter TV, and we're very pleased to be joined today by Markus Wagner of Siemens Energy and Søren Kildedal of Advent Technologies to discuss a recent MOU signed by their organizations regarding collaboration on an integrated fuel cell solution. As I alluded to in the introduction, we're here today to talk about the Siemens Energy and Advent recently signing an MOU, the beginning of a collaboration where you'll be working on an integrated fuel cell solution. Can we start out with a detailed look at the project, a by the numbers look at the resources that each organization will bring to the project, a timeline, and a best scenario conclusion?
Yeah, thank you for that. I will start by saying it's not a single project. It's a collaboration on multiple projects, and the ambition is, of course, to build up a firm backlog for the solution that we are doing together. And that's from Advent's side. We bring a lot of know-how on how to do marine fuel cell solutions because we already have a solution on the market today. And together with Siemens, we will ensure to have the next generation for higher power demands on the market. Regarding resources, we are dedicating around 50 R&D personnel for this development, and you can say we also bring the know-how of how to do this approval for methanol fuel cells in the configuration that we do toward following the IMO definitions of how to do a safe system and ensure that we comply with all the regulations.
And the resources we bring in, I think it's difficult to quantify because we hope to have some more projects and installations in the future, and then it comes up to a bunch of employees that are involved in this, so from financial departments to worldwide service that we can provide. And I think that's a good point where we fit together the Siemens Energy worldwide network for service, for example, and the solution from Advent regarding high temperature PEM fuel cells.
So, when talk turns to hybrid propulsion and alternative fuels in the maritime sector, as you both know, there are many options under study. I know there are multiple projects involved in this, but looking at the fuel cell energy solutions that you're looking at, can you tell me the strengths and the weaknesses or the limitations?
You can say what our solution gives with the methanol-driven fuel cells. It's possible to go to net zero emissions. There's a very high efficiency on fuel cells. It's compact. It's noise-free, vibration-free when it's in operation as well. So that you could say it's some of the big things moving for fuel cells. If you look at the more, you can say on land, you have already now converted to electricity in different applications, and here you can say some of the difficulties in going into electricity is that you need to store a lot of energy, and this is not possible on the marine applications because you need to store that much energy. And this is where methanol comes into a good play in this role, being able to store a lot of energy in the very limited amount of space that you have, and then convert it into electricity with our fuel cells technology. And the higher, you can say the weakness is more, there's a lot of capital investment when you start up compared to traditional polluting internal combustion engines. And so there's pros and cons on going from one to the other, but the main purpose is this can go green.
But there is always some point when it comes to bigger devices where it makes sense to use a fuel cell. So fuel cells are now for trucks a possible solution that many companies go for. And if you look at a vessel that's much bigger than a truck, then you will see directly that it's not possible to go over the ocean with only battery installation, for example, because the batteries are just too heavy and the energy content is far less than in some hydrogen carriers like methanol. And then you can choose which hydrogen carrier to use, and then you quickly come up to methanol because the energy content is around 4 times higher than compared to compressed hydrogen tanks, for example. And then I don't see another solution at the moment to go over the ocean in a sustainable vessel than methanol. For sure, there are other fuels as
you can say, if I should add something regarding the methanol, it would be how dangerous ammonia is for the environment. Like it's 225,000 more deadly for the fish than methanol is. So considering the environmental impact a spill can have in the ocean, methanol is an obvious choice for that. And going for pure hydrogen solution, even though you cool it down and so on, and you store enough energy, normally you would say hydrogen do not have a global warming potential. But actually, if you look into the tables of global warming potential, then hydrogen is actually an accelerator of this. So this has a factor 8 to 12 times more impact to the environment than CO2 has. And those things you avoid by going for a fuel that doesn't have these impacts.
When talk turns to alternative fuels and power, it's generally agreed that there is no silver bullet solution. For the technology in the confines of these projects that we're discussing, what types and sizes of vessels are we talking about? And if possible, can you give an overview of the expected emission reduction?
So looking at running on methanol, and if you go for the e-methanol, that would be the long-term solution for methanol production. So methanol produced from electricity and carbon capture. Then you will have reductions of something like 97 to 99% CO2 reduction in your full cycle.
Good. What kind of vessels is a good choice for methanol? Then I would say definitely the big ones going huge distances, because if you use methanol, you need to find a way to get hydrogen out of it, and therefore you will need some space for reformers for the reforming process to get the hydrogen. And if it comes to very small vessels, it could be an option to go with pure compressed hydrogen to save the space for the methanol. But what's for the methanol reformer? But what's let's say attractive thing with the Advent solution that we found very attractive as well is that they built these modular small systems with an integrated reformer. So in the end, you could even use a small speedboat and put in one of their smaller fuel cell systems with integrated reformer and charge the battery always like a range extender. And then in the end, you end up to a similar solution like compressed hydrogen. And that makes the solution very attractive, the scalability. And yeah, you can cross the ocean with a container vessel with compressed hydrogen. So that's the best solution for my point of view.
So I know we're just at the beginning of this, and I know this is a multiple projects, it's not one project, but when you look at your collaboration, what do you see as the greatest challenge or hurdle for a successful conclusion?
I actually think it's getting the very conservative marine industry to adapt to new technologies, and hereby increase the production volume and have a full serial production. That will significantly reduce cost of production of systems. So I actually think that's the biggest challenge. But of course, there is many who is doing the fuel supply, who is doing the service, and that's where you can say all the benefits come from joining up with one of the major players in the market that actually have an organization and already has established this infrastructure for multiple of the challenges that are for going into a market with a new product.
I think one big thing is the availability of methanol. So for sure, the production of methanol needs to keep up with the production of methanol-based fuel cell systems. And that's why we see a lot of movement here in the market, like Maersk going into the production of methanol for their container vessels, but as well Siemens Energy is involved in many projects to produce methanol. And only if this production can keep up to produce it sustainable, for sure, then we get the drive we need to have a future and sustainable shipping.
Søren, to your point, you know, I've been doing this for 30 years, and I know the maritime industry is obviously very cautious for reasons, very conservative. You know, but when you look at the world around you, are there any case examples within maritime, even if they're outside your organization, that you can point to as a success, or at least we're going the right path?
Yes, I can. You can say already in 2015 we did our first marine installation on a ferry that got class approval. So yes, we have done it ourselves already back then. We have done a few others since that also have the approvals on it. We are right now doing an installation together with Siemens Energy on a yacht in Italy. So I actually think we're on a quite good track. But obviously with more and more shipping companies, that could be container vessels, but it could also be other vessels that are converting towards methanol as a fuel, then obviously it's easier coming in with a product that's running on methanol, so you don't need to do all the work saying what tank do you need, how do you do your piping, how do you do everything, because this is suddenly getting more and more common knowledge for you know, everybody within the industry. And actually today I was just informed that Lloyd's Register also came with a report referring to some of our systems and showing that there is actually a path here through this web of difficult rules to follow.
Yeah, for sure. We have seen a lot of successful solutions based on methanol in the shipping part. Mainly, I would say in the past based on compressed hydrogen, and that's a solution where we started up my project as well. But pretty soon we realized that there are a lot of concerns regarding compressed hydrogen because it's dangerous and you have to do a lot to make the system safe on the vessel, and this needs again a lot of space. So if you need double walled pipes and stuff like this, and there methanol for us was a more attractive solution.
I'm certainly not looking for you to speak for ship owners, but can you generalize the hurdles that you face in making ship owners comfortable with these new emerging technologies?
Yes, I'll try to do. You can say it's always important to understand how the owner see this, and also ensure that the risk for the owner is minimized as much as possible. And this is where we from Advent side see it as a big opportunity with the partnership with Siemens, building up this, because trust, and this, you can say that the large industry partner like Siemens Energy, they are giving some trust into the market, and I'm sure that Markus can definitely say that they have done a very thorough investigation of Advent before going into this.
And one of the pain points we encounter when we get requests for fuel cell systems from customers, maybe one can tear down to just being not experienced or not having much knowledge about the different systems. So they need to learn a lot, and we try to tell them what are the differences, and for sure we see more examples than disadvantages. And as Søren already said, the capex is the biggest pain point in the first place for the customers, but we try to tell them or show them, don't look only at the capex, have a look at the OPEX. If you run the system for 15 years, for example, you probably will be spending less money than if you use an internal combustion engine based on methanol, for example. We heard from customers having technicians on the vessel all day on big container vessels, and there's always one machine in repairs, and you need to pay these persons as well. And if you have a fuel cell system with no moving parts, it's much lower in maintenance costs. And this sums up in the end. And these are small differences. And it's not that complicated as well. If you look at the interfaces, what do you need for a methanol-based fuel system like we did? It's only air. You need a DC connection. You need a communication connection for sure. You need some cooling water, and you need methanol, and that's it. The methanol, you don't even need water because we created a solution where we have a internal water cycle. So the water we produce from the fuel cell, we catch it back and use it to mix it again, and you save space again, not carrying water. So in the end, it's pretty simple and cheap over the years.
You know, finally, it's the big question that I'm sure you deal with on a daily basis, and that's when. The fuel cell technology that you'll be looking at, can you give us a timeline or a time frame or a best guesstimate of when it might become more mainstream in maritime?
The first part of the question, when does it come out of the test tank? It's already out there. It's not in the test tank anymore. It's out there. And then you could say, when does it get mainstream? And that's a really good question, because what is actually mainstream? And now it seems like those that are building new ships, they prepare everything from methanol, at least in some of the sectors. They are saying we need to be prepared for the future, so we prepare the ship from methanol. Many are already saying they run on methanol. So it's more we are ready. We believe there will be a significant amount of new builds and retrofit by that will have Advent and Siemens fuel cell solution over the coming years.
What we face every day, one could say, is the big demand for fuel cell solutions based on methanol. It completely changed over the past 2 years. I don't know where they are all coming from, but it seems like every customer wants to have one of these systems now, maybe because the others do it, or maybe they know the advantages. For example, if it comes to CO2 taxes that will come up and will get more and more expensive. So we see a lot of cruise liners asking for the systems, and even some are very experienced and spend some time looking into the different technologies and comparing it with methanol combustion engines. So you have both. You have some customers, they don't know anything about it. Some already know a lot about it. And yeah, I just can say from our view, from our company, that there's a lot of interest, a lot of companies, especially megawatt systems, cruise liners, container vessels, are asking for these systems. And like Søren said, that we don't need to wait for the technology, it's already there, and we just need to ask the customers to give us the time to build the system, the systems to implement it, and then they are good to go.